Our aircraft design underwent three phases of iterations. The first aircraft was structurally robust but heavy. The second incorporated lightning holes for mass reduction. The third and final iteration optimized material use while maintaining structural integrity. We designed an aircraft with lightning holes concentrated at the rear to shift the centre of gravity forward to reduce weight added on the nose. Modelling the catapult launch and flight parameters and mass balance was used to measure the elastic force of the catapult at different launch extensions. These values showed a near linear relationship between extension and elastic energy. We obtained the coefficient of drag from data on a Clark-White airfoil. The value of 0.05 was approximated within the typical range for an angle of attack of 12 degrees. The coefficient of lift was refined to match the simulated flight trajectory to the flight test on week 10. Thereafter, the coefficient of losses was calculated by comparing experimental launch velocity from the video analysis with the theoretical value. Launch phase modelling found that the ideal velocity for an aircraft mass of 0.561 kilograms required a launch velocity of 5.62 meters per second to reach the target of 18 meters. This made us choose catapult position 7 for our launch, as it was the next closest launch velocity at 5.86 meters per second, though in reality the launch velocity was measured at 5.74 meters per second, with a simulated landing distance of 18.97 meters. This proved that our spreadsheet analysis was able to accurately replicate our actual test results with marginal errors. A static FEA was performed on the final aircraft model. An upward load of 5.5 newtons was applied to represent lift, resulting in a maximum wing deflection of 0.39 millimeters and a fuselage deflection of 0.44 millimeters. With a safety factor greater than 1, this indicated acceptable deflection under our aerodynamic load case. To quantify the effect of our lightning holes, we compared the solid non-perforated original model with the final design. Our analysis ensured structural integrity of the airframe while achieving an approximate 26% mass reduction, validating the design trade-off. The spreadsheet used a constant drag and lift coefficient. We assumed two things. Conversion of energy from elastic to kinetic is ideal, then applied a coefficient of loss. Then, the relationship remains linear from 0.6 to 1 meter extension on the catapult due to the lack of data on the extension in this range. Next, our static FEA only considered aerodynamic lift, omitting the point load acting on the empennage of the aircraft during launch, which was one of the reasons leading to the fuselage failure. Lastly, we assumed cardboard was a homogeneous material with uniform isotropic material properties for modelling purposes in CAD analysis. Aircraft's flight characteristic in the spreadsheet analysis was validated through flight tests in week 10. By launching our prototype and measuring flight time, landing distance, and trajectory shape via video analysis, we iteratively adjusted parameters until our simulation matched empirical data. The final design achieved the 18-meter target, validating our mass reduction strategy. However, compared to our straight and gentle postulated trajectory, we observed our aircraft veering to the right. We postulated that the loss of directional stability had resulted from wind gust when the building's doors were open. We were limited in our experiments due to the frame rate while capturing our slow-motion videos, hasty and non-ideal manufacturing conditions, and structural fatigue between test flights. As an experimental finding, we found that the fuselage was bending after several flights. That revealed the limitations of our initial modelling and manufacturing imperfections, as deformed structural parts increased skin drag and losses over time. We established a structured approach to productive meetings by actively recording meeting minutes, resulting in the successful design of 3 aircraft with multiple optimization iterations to achieve the lowest possible weight within the project deadlines.